I know him for 9 years, working together with him. He served overseas in some perilous places, but does some really cool, great way at wrangling people and getting them together and getting stuff done. Very nice person. If I was in a car accident, I'd call him to come rescue me, right? But also, he is a master in jujitsu, and he is skilled in many different ways to choke a person to get them into submission. So please welcome to the stage, by his fake name, Jake.
All right, thanks for having me here today. I'm from Certus Group. We're a data knowledge engineering solutions company. And like Jared said, I've worked in government quite a long time, like 23 years. Last 10 years, I was a government civilian. I met my other two founders. We came together trying to provide solutions. We found out there was a lot of data engineering solutions that were relevant to government. So I'm here to talk a little bit about what we did while we were in government and then what we're doing now, how that relates to you guys. So as far as, as far as geopolitics goes, we think we're in a critical point in history. Data is really ubiquitous and it's really eroding a lot of the national advantage that we've had for quite some time. Jared likes to, have this joke with me that I'm like a proto-hipster because I've been doing data since before it was cool because I was in the community. But the reality is, it's like we used to have all of these systems that just gave us data and we didn't get data from the outside. And now everybody wants to get data from, commercial sector. It's producing so many different data products. So defense, national security leadership says, yeah, we need transformative innovation, to help strategic competition. Industry has been disrupted by data products. And most of that new thinking that's coming out is like, hey, give me more data. Well, data's, like Mark Twain said, data's like garbage. Just add more data, it'll be fine. No, I'm here to tell you it won't. Like, it won't be fine. You need to have a plan. You need to know what your questions are. You need to know what your concepts are. This have a problem, get data for it syndrome is not good. Think through those concepts. Think through those questions. Turn those concepts into ways to constrain your data. And I'm saying all this and I'm being a little bit preachy, but I've been there, homie. Let me tell you, I am a self-professed data addict. I would go and this is one of the projects that we did towards the end, get 40 plus terabytes of data. I would get Bank Secrecy Act data, I would get satellite data, a whole bunch of different data sets to integrate as a solution. I would go to a variety of geographic combatant commands as part of my job at the R&D facility I worked at, and provide them solutions. They usually didn't have data. Now I would try to find something commercial and engineer something that they could utilize, but it's not necessarily the right path to just get more data. You need to come up with something that will organize and constrain that data and help you answer the questions. So in this one problem I'm going to tell you about, it's kind of extreme case of way too much data, but it was purposeful. We got over 40 terabytes worth of data, no images, no videos, just text. We bought all of what chain analysis had at the time. Why? Because we're the government and we spend lots of money. And, we bought all the Bitcoin, Litecoin, Ethereum data, Solana data that they had, integrated over 3 years worth of container shipment data, U.S. Treasury, Bank Secrecy Act data, had a bunch of different shipping transactions, cryptocurrency transactions, and lots of variability in structure. We had unstructured, structured. The Bank Secrecy Act data had 93 different fields, and each one of those reports was actually an investigation that a financial institution submitted that was really a roll-up of a bunch of different transactions that they looked at for maybe years. And we had like, was it 90 million of them? So a lot of variability in the data, over 1 billion distinct entities. So what we did is we focused on our questions, and then we came up with constraints based on those questions. And we really focused on effects that we were trying to generate with those law enforcement partners that we had. We were doing money laundering operations at the time. So we looked at sanctions. We know that we wanted to support law enforcement, drug operations, money laundering, and then identifying sanctions related activity. So we really focused in on how to create a structure that would enable that. So this is kind of like a toy version of an ontology that we created. But you see there's kind of variability in the entities and the relationships that were up there. The point of showing this is, this isn't what was in the data. This is what we transformed the data into. And we left data on the floor. Like, quite a bit of data on the floor because this is the stuff that we needed. So we created, transformation pipelines to create that, top level ontology. We didn't want to be too prescriptive. There was lower level, there'd be a lot more change to it, but that upper level is what we really focused on. And that was able to answer, which sanctioned entities involved in what commercial behavior, what companies, what shipments, and the relationships were key. If you look up there, you have that variability between, the person is in this location, but they've transacted with this financial institution. So you can ask different questions and be able to answer, hey, what people are associated with what company, who shipped these goods to what location, and what sanctions program is that connected to? And all of that was available through a graph traversal, different type of query that we ran. So we did that. So what? Well, it enabled more rapid targeting. We worked with one geographic combat command. They had a targeting shop. They would do it manually. They would go through not this data, but some of it. They had some of the data, and they would generate a target really every 30 to 45 days, one target. We got it down to every 30 minutes. We trained an analyst on how to do queries in Gremlin, and we said, okay, here's the graph that we created. Go to town. In 2 weeks, the guy did over 135 targets. And that 30 minutes wasn't, all the queries that he ran. That 30 minutes was like, oh, what is this? I found something. Is this a real relationship? Is this not a real relationship? Were there errors in that data engineering process? He was just really validating a lot of those relationships. So that wasn't query time. That was, his investigation to identify. And then there was a lot of, unknown connections that were made. And then, the government does what the government does, created a program office and tried to productize this thing. And we had bought a bunch of commercial software. So created a pipeline, a bunch of people they're now doing this for all of defense support to law enforcement. And that's great. But we came up with these ideas and these processes, and we thought, hey, we can do something with this. This has broad applicability. And that's really what I'm here to talk about is like, if you go back to the effects you're trying to generate, and the military is great because, they have all of these orders and these plans and they write down, okay, we're trying to disrupt these people and that's the effect we're trying to generate. But, even in your organization, even in business, they have effects and things they're trying to do, concepts that they want to identify. So I'm going to show you an example of a commercial application of the same kind of thinking. And we created some software that, demonstrates this thinking as well. So I'll give you a toy problem that a lot of services companies have. Is the juice worth the squeeze, right? Hey, I'm working for this person. They're giving me a lot of revenue. I'm doing a lot of invoicing, but what are my expenses associated with that? How much money did we get for what we did? That's a common, commercial related problem. So we created this toy ontology that you see here. And a lot of ontologies are a little bit more complex, have more hierarchy, but they don't have to be. They can be really simple as long as you're interrelating your data. And you notice those key differences in the relationship types, services, belongs to, works on, and that's reflected in the data. And, we're taking data from 4 different systems. We have our notional ADP data, Jira data, Salesforce data, QuickBooks data, stuff that doesn't normally fit together. You'd have to download or hit an API, something like that to generate. So what I'm going to do is show you a video of what we were able to do here. So you see that same ontology there on the left part of the screen, or my left, your right. That's what we're using to engineer the data. So we had already done the data pipeline, and we're going to show you a query of what we're running against today. So you can see some of the relationships that we created. And I'm going to zoom in on one of those fields there. Looks like we have a company, Soylent. They had this Charlie Charlton, maybe is what he goes by, had a project called Different Green Tank. And you see all of the different relationships there, invoicing, expenses, charged to, belongs to, and it's all showing up as the fields there on the right-hand part of the screen. And I think we're going to switch to a different query here in a second. And this is a very engineering-heavy, solution, engineering-heavy visualization. This isn't meant for like that final exploratory data analysis product, but this is just to verify, hey, I did my engineering correctly. So now we're going to change some of those charged to queries and then put in services-related queries so you can append that existing graph and see like, okay, I really did add in those employees, Miles and Arnie, to that Cyberdyne Systems project that they were working, something associated with Terminators. And then, they had bills that we invoiced to them. Okay, so you can see all of the relationships there. Now that I've done that engineering and I've looked and I see, okay, I have all these relationships, let's get the data, let's download it, and let's do something with it. So that's in essence what we did. So after we downloaded that, and I'm just going to zoom in really quick so you can see, now you'll see all of those relationships together in that table. I know you guys probably can't see, but there's invoices, they're connected to the different projects, connected to the different customers, all together in one consistent data product. And that consistency is actually really key. If you want to be deploying models on, you want a consistent data product. So going through the analysis, back to the original question, and this is the key part, you're answering a question. That original question is the juice worth the squeeze? You go to that time spent on each customer table, and I did this in Looker and a combination of Looker and Excel just to show that it was possible on that flat CSV that we generated. Down on the right of that time spent on customer table, see Glengarry Glen Ross as the person that, or the company that they spent the most amount of time providing services to. And if you go to that percentage of revenue from each customer on top, that's the biggest revenue for that company. But that client value score, Glengarry Glen Ross score, is all the way kind of towards the back. And the number one is this other company, Soylent. And the point I'm trying to make is that those relationships and that integration and those questions really matter to how you engineer the data and how you do your data pipelines and how you provide that consistent product that you then deploy your models to. Another way of saying it is you're trying to add context, and that context enables the understanding and informs decision-making. So this little triangle example here is like showing you, you get raw data and you try to create information and meaning, but the context of how it relates to that individual or that organization is really the part that you have to implement. So the raw data, in this case, it would be 3 backlit colors, red, yellow, green. You go to information and meaning and like, okay, that's a traffic light, and it's at the southern part of this intersection. Okay, but the context and knowledge related to that is I'm driving at that intersection. I'm driving at that traffic light that's red. I better stop. So you really need to have ways to add in that context and just have a plan for your data. Know what questions you're answering, what effect that you're trying to generate, what's that overarching strategic goal, and then ask your data, hey, like, what is it that I'm trying to do with you? Maybe the data that you have internal to the organization isn't the right data. That's okay. You can go get other data, or you can collect data within your organization. There are surveys, there are ways to go and procure data. Maybe the data you have isn't right for the question. And that's something that you need to come through in your analysis. Data operations is a thing, data management, data governance, data lifecycle management combined with content management and task management. That's something that you should do. We have an open source ebook that just click the link, go to it. It'll show you how to do it. It's tool agnostic. It's out there. We want people to do it. I was very happy to hear Murad yesterday talk about how Data Society is doing it and training people. Please do implement some of those basic data management skills, data governance skills. But most importantly, turn your questions into concepts and then use those concepts to constrain your data in some kind of engineering format so you can get a consistent data product that will answer your question. And that's really the point I'm trying to make is bring those questions to your data, make something that's not necessarily like what the data is, and then transform the data to it. And if that data isn't the right data source, you'll have some kind of metric of value, because the most important thing isn't the data. It's your question. It's the strategic goal. It's the effect that you're trying to implement. And that's pretty much all I had to say.